Nintendo Switch, no power. What's the first thing we always check? Well, the first thing we always check is the port, so let's take a look real quick. And in this particular case, the port actually looks fine. It is structurally sound, no bent pins, pristine. This video is brought to you by PCB. They're running some huge specials. We'll talk more about them in a little bit. It should be safe to perform some power tests. So let's perform the first one with our bench top PSU. We're looking at PSU channel 1, and we want to see what kind of current is drawing here. This is at 5 volt, and we're drawing some weird current. Okay, so the next test we want to perform is with the USB-C amp meter. Sometimes I don't show this in video, but this is a very important test. You need to see if the charger is communicating with the M92T36, and the way you do that is you see if it's drawing 5 volt, or if it's drawing 15 volt, or if it's drawing no voltage. And as you can see, it is pulling 14.9 volts, which means it is communicating with the M92T36. So we need to crack this open and do some testing and see if we can find the fault. We have it apart enough to do some initial testing. These are our common fault testing zones, and this is where we'll be testing. Even though it's in the housing, this is the orientation we'll be testing in. We'll be starting at the M92T36 and working our way towards the port, and then to the BQ24193. We're going to begin our testing around the M92T36, but the capacitor we're going to test first is actually tied to the Pi 3 USB on the back of the board through the M92T36, and the line we do not want shorted to ground is the line going to the chip. Okay, and that line appears to be shorted to ground. That's not a good thing, so we definitely have a Pi 3 USB problem at the very least. Let's continue our testing around the chip. Same deal, the lines typically going to the chip we do not want shorted to ground. This capacitor right here is an exception to the rule. It has 2 lines going to the chip. In that case, one side will always be ground. That side. Okay, the rest of the capacitors seem okay. Let's move our way up the board towards the port. We'll check our MOSFET area. Everything seems to be okay there. We'll check our invincible fuse. See if it's still being invincible. It is. Now we're going to check our test pads. They can be very illuminating when other things are not. None of these test pads should have a pathway to ground. These test pads here should not have a pathway to ground. I'm seeing a little liquid damage here, and on the BQ. Let's check and see if this coil has a pathway to ground. It does not. Does it have continuity through it? It does. That's good news. We'll definitely need to clean around the BQ24193. The BQ24193 has several capacitors with multiple lines going to the chip. Same deal. In that case, one side should be ground. More liquid damage here, but nothing shorted to ground. Okay, so we know we're having a problem on the other side of the board in the Pi 3 USB area due to this capacitor being shorted to ground on this side, on the line going to the chip. And we know we have a little bit of liquid damage here by the BQ24193 that we need to clean up. Let's look around the rest of this board and make sure there's not more problems. And I'm not seeing anything right offhand, so next step is we got to take the board the rest of the way apart and take a look at the other side of the board. I need to release the adhesive on these 2 foam pads. In order to do that, I'm going to set the hot air temperature to 130 degrees. Unless the adhesive is extraordinarily old and worn out, 130 degrees is the optimal temp for getting it to release. And as always, on this ribbon right here, you want to back it out. You do not want to flick it out. Save yourself many tears. Now that we have the board out of the housing, we can look over on side A, and these are going to be our common fault testing zones for side A. This is Pi 3 USB area, and we're also going to investigate the rest of the board because we saw some spotty liquid damage on the other side of the board. So first, let's take a look at the Pi 3 and test again and make sure we are actually having a problem in that area. Let's check our Pi 3 USB. I'm going to check this big capacitor right here, and the same rules apply to this one as all the other chips. The line we do not want shorted to ground is the one going to the chip. And strangely, it is not shorted to ground. Could have swore we got a reading that it might be short on the other side. We'll have to retest that and see if we're getting false reading. But while we're here, let's check our filters. We do not want any of these filters to be shorted to ground. None of these are a ground line. But we want continuity going from the chip to the port, basically. We do not want continuity going side to side. Everything is actually checking out in this area. Let's take a look around the board. And yikes, that's some water damage right there. Got a little bit of spotty water damage there. And we have water damage under the fuel gauge IC. That could be a problem. Alright, so this is our big problem area to start with. And the biggest problem is right there on the fuel gauge. That will affect our ability to have power to the switch. For your orientation purposes, we will be working on this side of the board, side A, in this area, which is where the fuel gauge is located. So unfortunately I did not record what I did next. With our ultrasonic toothbrush, we cleaned up this area. We also did some cleaning around this area, and we did a flux and boil on the fuel gauge. We'll have to test and see if that solved the problem. We still have other problems to deal with before we put power to this board and test it again. For your orientation purposes, we'll be working on this area of the board. That is where the BQ24193 is located, and that's where our other problematic areas are. And there's some nastiness going on here, but I think most of it can be dealt with using our ultrasonic toothbrush. I am very sad I did not get the actual rework on film. My apologies. This may turn out to be a boring video of me toothbrushing a motherboard. Double check and make sure we don't have any other spot damage. And I see none. Very good. We're going to pop back up to the M92T36 and test that capacitor one more time. And I am not reading a short there now. Very strange. Okay. PCB Way is celebrating their 9th anniversary with a huge promotion, with special offerings like free coupons, specials on PCB services, up to 50% off for 3D printing and CNC machining, and all sorts of sales in the PCB Way store, and much more. Head over to PCBWay.com and start your project today. Did we fix our problem? Let's find out. Okay, that looks relatively normal. What we want to see with this particular test, when it works, it doesn't always work, is a quick jump up in current and back down, both sides preferably. And like I said, it doesn't always work. We do not make any definitive conclusions using this test. This test is far more conclusive. We're now using our modified iPhone Power Squid, which we have retrofitted with Nintendo Switch and Nintendo Switch Lite battery connectors. In order to activate this, we will use our OEM charger. Alright, what we want to see here is a steady climb in current, and it's looking good. It looks like it's booting. Next important test is to see if it's docking. Whoop, there it is. Okay, so that makes it reasonably certain that the port is working fine on both sides. If we had any problems, it would not be docking. Next thing we need to do is put it back in the housing, let it charge on its own battery for a bit, and we'll test it from there. I'm not going to torture you all with the whole reassembly, but the biggest trick for not damaging this LCD connector is to plug the ribbon in before you put the board in the housing. I learned this from Phil, the coder. Must give credit where credit is due. It was a life-changing moment. Like so. I hope this video is being helpful to you in your repair journey. Just a reminder, if this is something beyond what you want to try yourself, I do offer these services. Just head over to micromage.repair, click free quote, fill out the form, and I'll get back to you personally. I believe there's something wrong with their battery. I tried to put it on charge and it wasn't working, but I've got my donor battery attached and it is charging now. It's pulling 15 volts, 0.29 amps. We can switch over to our PSU so we can test both sides. 0.53, switch over to the other side. 0.53, 0.52. I tried to externally charge their battery using this wonderful little device created by one of my viewers called Roy. And I also tried with my poor attempt at one of these. So on Roy's, it's showing it's full, but it will not take a charge. I've actually never seen a battery that would not take a charge from one of these. And as you can see on my little makeshift one, we're getting a little flickering red light, but the blue full light as well. So there's something wrong with the actual electronics board on their battery, and I think they're just going to have a battery replacement. The shop is going to have to handle that, unfortunately, but it has nothing to do with the board. We have fixed the board. It is charging my battery normally, which is excellent. And just to demonstrate what you would normally expect to see if it were charging the battery using Roy's device, you expect it to see red until it gets full, and then it would show you green, and there's your percentage. Very cool little device. If you got value out of this video, I think you'll get value out of this one, and I'll see you there.